Alright, today we are going to graph quadratics when we're given different values. So this is from the Google Slides activity where you have to fill in all of the key features of the quadratics. So I believe this is number 2 from that activity, and they have given us vertex form. So from vertex form, we are going to use that to find standard form by actually multiplying that binomial and then solving it. So x minus 2 times x minus 2, you can use the FOIL method, you can use the box method, you can use whichever one you prefer. I believe last time I used the box method, so this time I'm just going to use FOIL. First times the first, outer times the outer, inner times the inner, and then last times the last. So that's going to give me x squared minus 2x minus 2x plus 4, and then we have this minus 4 over here. Okay, so now we can just combine like terms. In this, the like, oh no! Whew, I pressed the wrong button. In this, the like terms are the negative 2x and negative 2x. So that's going to leave us with x squared minus 4x. And then positive 4 and negative 4 are actually going to create a zero pair. So our standard form of this equation is y equals x squared minus 4x. Next, we're going to use that to find our axis of symmetry. You'll see that I left this formula up here for you to find your axis of symmetry. It's the opposite of b over 2a. So the opposite of our b value over 2 times our a value. That means we need to know what a, b, and c equal. In this case, a is 1, b is negative 4, and we don't have a c, therefore it's 0. So over here for our axis of symmetry, we're going to put in the opposite of negative 4 over 2 times 1. Well, the opposite of negative 4 is positive 4. Divided by 2 is 2. So our axis of symmetry is at positive 2. So therefore, on my graph, I will draw a vertical line. Remember, it's x equals positive 2. And I apologize, my line's not quite vertical because I'm drawing with my finger. But it's at positive 2. The other thing that that axis of symmetry tells us is that that is the x value of our vertex. So we're going to use that to help us with our vertex. And if it's okay with you, I'm going to get rid of this pink so I can write right there again to find the other information that we need. Alright, so if we know the x value of our vertex is 2 because of our axis of symmetry, we can solve for the y value of our vertex. So, if the equation is x squared minus 4x, then I can plug in 2 as x, 2 squared minus 4 times 2, and that will give me 4 minus 8, which is negative 4. So the y value of my vertex is negative 4. So I can go ahead and graph my vertex over here at 2, negative 4. And then I can move on to finding my other points. I find my other points by using the same equation and plugging in different values of x. If I know my vertex is at 2, I know I need to know a point that's at 3 or possibly 4 and a point that's at 1 and 0. Well, I'm going to start with the one that's the easiest for all of us. 0 squared minus 4 times 0 is what? 0. So I'm going to go ahead and graph the point at the origin of 0, 0. And then, since I have the axis of symmetry, I know that since this is 2 spaces away from the axis of symmetry, there has to be a matching point over here that's 2 away from the axis of symmetry. So now I can see my parabola. I'm going to draw it in a color so you can see it better. And it's a rough sketch. You're just going to, on the activity, you drag the parabola that they have. Make sure that you have it touch your vertex down here, and that it goes through the zeros, aka roots. So now we know our zeros, also known as roots, solutions, x-intercepts, and that, whoa, I don't know what just happened there. Sorry about that. Those are at 0 and 4. Next, it's going to ask us for our domain, which is all real numbers, because these arrows tell us that it's going to keep going forever and ever. And our range is going to be all of the possible y values, which in this case starts at our minimum value, which is down here at our vertex, and it goes on and on and on. So y is going to be any number that is greater than or equal to that minimum y value, which is the y value of our vertex, so -4. All right, our next example comes again from the Google Slides. It's number 3. They've given us the graph already filled out. They've also given us the vertex. We could have found it from the graph, but they already gave us the values. And then they gave us vertex form. So we're going to do what we did last time we started, and we are going to take that vertex form, and we are going to multiply that binomial times itself, and then simplify to get standard form. So x plus 5 times x plus 5, if you want to see it in the box, x times x is x squared, 5 times x is 5x, 5 times x is 5x, and 5 times 5 is 25. So once we write that down here, x squared plus 10x, because remember you have to add these two 5x's together, plus 25 minus 1. The only thing we need to combine are these like terms right here. So 25 minus 1 is 24. So our new standard form that we're going to type into that Google slide is y equals x squared plus 10x plus 24. Okay? Looking at the graph, you cannot see your y-intercept because the graph continues really high up here. But a trick to knowing understanding your standard form equation is that your c value is always your y-intercept. So our y-intercept in this case is 24, positive 24. So every time you have standard form, you already know your y-intercept. So now we're going to use A, B, and C. And we are going to find our axis of symmetry. Okay, so our axis of symmetry formula is the opposite of B over 2A, which in this case is the opposite of 10 divided by 2 times 1. So negative 10 divided by 2 is negative 5. So our axis of symmetry is at x equals negative 5. Remember that an axis of symmetry is always a line, so you have to give it the full equation, that x equals negative 5. We are going to attempt to draw our axis of symmetry here on our graph. I think I'm better with my finger than I am my mouse. Let's see here. There we go. Our graph is already there for us, so we don't really need to do much else with it. We can use this graph to tell us what our roots are. So our roots happen, I picked a color that's too hard to see. Our roots happen where we cross the x-axis as our solutions. So in this case, our zeros, roots, and solutions are negative 6 and negative 4. Okay, so we have our vertex form, standard form, our vertex, our axis of symmetry, our y-intercepts, and our zeros. So all that's left, I believe, is the domain, which for all quadratics is going to be all real numbers or negative infinity to positive infinity, because our graph can always keep going. And then our range is going to be, in this case, we have a minimum value because the lowest value you can have is at our vertex of -1. So it's going to be y is anything greater than or equal to -1. All right, now I'm going to do 2 examples from the Google Forms. This is a little bit farther down the Google form. I'm finding a lot of students are having trouble with it, so I just wanted to talk you through it really quick. It's not exactly complicated. I think we just overthink it. So if you're trying to find when the graph is increasing, use your knowledge of slope. And when slope is positive, that means it's increasing. So this graph is increasing as it goes from left to right until it gets up to its vertex. So I'm going to look at my x value and determine where it starts that change. And it's starting that change at -2. Now, if it's asking where it's increasing, it only cares about this left-hand side of the graph. So it's saying from -2 and down, this graph is increasing. Because you're not talking about the direction you're going, you're talking about where the graph is a positive slope. So when y is less than -2, your graph is increasing. That being said, the opposite is when you're decreasing. When do you have a negative slope? You have a negative slope from your vertex and to the right, because that's when your graph is going at a downward angle. So your, oh, I messed up here. This should have been an X. My apologies. The Y habit is strong. All right, so when is your graph decreasing? Well, it's decreasing from when x is -2 all the way up to the positives. So every time x is greater than -2, your graph is decreasing. That's one of the examples from the Google form. The final example I'm going to do with you is this multiple choice, but there's more than one that are right. So we're just going to look at the graph and pick out the important stuff. If my vertex is here, is that a minimum value or a maximum value? It's a maximum value. Okay, so this I would select, which means the graph has a minimum value is not a correct answer. Okay. Then we want to look at our solutions. So what are these 2 points on the x-axis? We have -1, 0, and -3, 0. Remember that if you're on the x-axis, the y value has to be 0. So this is a solution, and this is not because it's written incorrectly. And a solution is where you cross the x-axis, not the y-axis. The axis of symmetry actually, I am incorrect. A solution is where it falls on the line, and since 0, -6 is on the line, that too is a correct answer. If it had said a 0 or a root, it would have to be on the x-axis. But a solution is every point on the line. So your y-intercept does count. My apologies. Is 0, 6 the vertex? 0, -6. No, that's the y-intercept. The vertex is up here at -2, 2. So that is not a correct answer. The axis of symmetry is straight down this vertical line, which is at x equals -2. So that is a correct answer. So you would select all 4 of these boxes to be accurate.